The problem that I'm going to work through right now is from the 4 alpha assignment. It's problem number 8, and we're asked to find the tangent line to this relation at the point pi over 2 comma pi over 4. And it's really a problem that happens in 3 stages. And the first stage is to find the derivative. And in both cases, both sides of the equation, we need to use the product rule in this case. So on the left side, product rule says we're going to get y prime times the second function plus y times the derivative of the second function with respect to x, which would be 2 cosines of 2x. On the other side of the equation, we're going to get 1 times the cosine of 2y plus x times, and I thought this is the trickiest part of taking the derivative, we need to take the derivative of this with respect to y, which is going to give us the negative sine of 2y, but then we need to multiply that by the derivative of the inner function, which in this case is going to be 2y prime. Okay, so we now have a y prime right here, and we have a y prime way on the other side of the equation, and we need to get this term and this term right here on the same side. And so when we do that, the equation is suddenly going to look like this. We have y prime times the sine of 2x plus 2x sine of 2y times y prime. And then on the other side, we're going to have the cosine of 2y, that came from here, and then we subtract this term to get negative 2y cosine of 2x. So we now take this expression right here, and we have y prime in 2 places. We need to factor it out. And then we divide by this expression on both sides so that we can get the y prime by itself. Since y prime is the same as saying the change in y over the change in x, I'm going to write it this way. We end up with cosine of 2y minus 2y cosine 2x divided by sine of 2x plus 2x sine of 2y. So I said this is a problem that really comes in 3 parts. That right there is the end of part number 1. And that's the trickiest part. And of course it's the part that if you do it incorrectly, everything that happens afterwards is going to be in trouble. So the next thing that we need to do if we want to find the tangent line is determine what the value of dy dx is at the particular point that we were given, which is this point. So I'm going to plug that in carefully. Cosine of 2 times pi over 4 minus 2 times y is pi over 4 multiplied by the cosine of 2 times pi over 2 all over sine of 2 times pi over 2 plus 2 times our x value is pi over 2 sine of 2 times the pi over 4. Ooh. So now we simplify that down. The first thing I noticed is that 2 times pi over 4 is pi halves, and the cosine of pi halves is 0, so I'm going to drop this term here. That leaves us here with a negative 2 pi over 4, which is going to be negative pi over 2, times the cosine of pi, which is negative 1. So those are multiplied together. In the denominator, here we have the sine of pi, and the sine of pi is going to be 0, plus we have, let's see, that would be a pi times the sine of pi halves, which is 1, which means that this whole thing is going to simplify down to pi halves divided by pi, which is 1/2. So I would call that the completion of part number 2. We now know what the slope of the tangent is going to be. Part 3 is this, and this is the quickest part. We want to write the equation of the tangent in the form y is equal to the slope times x minus the x value plus the y value, where the x value is 1/2, the slope is 1/2, the x value is pi over 2, and the y value is pi over 4. That's a perfectly good answer, but you'll find that if you distribute the 1/2 through, you're actually going to end up with 1/2 x, because the half times negative pi over 2 is going to cancel with the pi over 4. And so that's our best and final answer.